Hey everyone! In this video, we'll walk you through the complete data service workflow on the EG71, including data acquisition, data forwarding, device library, and data stream to achieve end-to-end data transmission. Log into the EG71's Web GUI. Each submodule takes its responsibility. Data acquisition handles device onboarding and data collection. Data forwarding publishes data to your target systems. Device library manages device models and codecs. And data stream logs all the communication between your devices and the gateway. The modular design just makes everything easier to maintain. Before we start adding devices, here's a tip. Go ahead and set up device models in the device library for each device type you'll be adding. This will save you a lot of time later on. Of course, it is recommended to do first, but not must required. EG71 gives you two options, the inbuilt device repository and the custom device repository. The inbuilt device repository comes preloaded from the factory with all Milesight node device models. That includes basic device info, payload codec, and selectable objects. The objects here can be exported for future batch edition requirement. If your EG71 is online, you can just grab the latest library directly. If you're in an offline setup, no worries. You can download the latest files from GitHub and upload them manually. With custom device repository, you can create models for any protocol, LoRaWAN, BACnet, Modbus, or KNX. We'll demonstrate one example per protocol, but feel free to create only the ones you require, or skip this step altogether. Add an LoRaWAN device models. Start by naming your device model. For LoRaWAN devices, EG71 allows you to select an existing Milesight LoRaWAN device model as a template. The basic information will be auto-filled. You can then modify the basic info, edit the payload codec, and manage the objects as needed. Objects can be edited, enabled for BACnet forward or Modbus forward for later integration. Select related objects that must be written at the same time with certain object, or deleted some objects if they are unnecessary. To add objects, EG71 supports manual entry by filling in the required parameters. It also offers a parse add function. Write the codec, run the parse, and if successful, objects will be generated automatically. But notice that if the objects already exists in the list, it can't be added again. Such as this battery object. If no suitable template is available, select None and choose the LoRaWAN protocol. You'll then need to fill in the information manually. A payload codec example is still provided for reference, but you'll have to add objects and perform all other edits yourself. Batch import and export of objects are also supported. Once done, apply the device model. Add an BACnet/IP and an BACnet MS/TP device model. Please note that BACnet MS/TP objects are configured identically to BACnet/IP objects. The protocol difference applies only at the network/access level, not at the device template level, and there is no forward option for BACnet. Add an Modbus TCP, an Modbus TCP, and an Modbus RTU over TCP device model. Please note that Modbus RTU and Modbus TCP share the same object-level configuration. The only difference is that RTU uses a serial physical interface, while TCP uses IP networking. Object configuration is identical to standard Modbus TCP/RTU. The over TCP designation refers to the transport layer only. Add an KNX/TP device model. For KNX/TP, data point type defines the value format. Access mode determines whether the object is read-only or read/write. If custom is selected, you must manually define the data length. You can also click Import to select the device repository.zip file from local path. After importing, the device will pop up the import result. But attention that when importing the files, the device will overwrite the repository instead of appending to it. It is recommended to add one or more devices manually, then export the files to check the format. And here's something handy: if you need help, Milesight offers customization services and can help you develop and pre-configure the device library exactly the way you need it. With device types in the library, adding devices is just a few clicks, perfect for batch adding many identical ones. Alright, now, let's move on to data acquisition. EG71 can collect data from devices across a whole range of protocols: LoRa, BACnet, Modbus, KNX, and I/O devices, each with different onboarding methods. Let's go through them one by one. If you already know which network your devices will use, you can configure it in advance under Device Access Network, so you can simply select it when adding devices later. The LoRaWAN network is pre-installed based on the gateway's frequency and cannot be deleted, though you can edit it if necessary. For other protocols, you'll need to create access networks manually. Be sure to configure the correct parameters for each type. For demonstration purposes, I've set up access networks for all protocols. In practice, you only need to configure what you actually use. Alternatively, you can skip this step entirely and configure the network while adding devices. The choice is yours. Let's start with adding LoRa devices and their objects. For Method 1, Manual Edition, here's what you do. Give your device a custom name, select LoRaWAN as the protocol type, and you'll see all the fields needed for LoRaWAN communication. Since Milesight LoRaWAN node models are already in the device library, just pick the right device model, fill in the device EUI, and the rest auto-populates based on the model's preset. Once you're done, click Next Step to move on to object selection. Now let's add objects. EG71 converts terminal device data into objects, which makes integration really straightforward. If you picked a device model in the previous step, all the forwardable objects for that model will show up here. Just check the ones you want. After that, you can always go to the device list, click Object Count, and manage your objects from there, enable, disable, or add new ones from the device library. But what if you're adding a completely new LoRa device from scratch? You can manually fill in all the info and move on, but you'll find that LoRaWAN devices don't allow custom objects. So you can just skip adding objects. Then when you set up data forwarding over MQTT or HTTP, you can add the entire device and leave the payload parsing to the upstream system. We'll show you how this works later in the data forwarding part. Method 2 is NFC Tap to Add, and this one's only for Milesight devices. Activate the EG71 and just bring the device's NFC area close to the EG71's NFC spot, and it enrolls automatically. If adding fails, the LED flashes twice. If successful, green light stays on for 3 seconds. Back in the device list, the system will match the device model from the library with the device's information, payload codec, and objects. You can also edit the device information if necessary. Please note that the device model of WS501/502/503 can't match automatically and needs manually selection on edit column. For objects, go to Object Count in the device list and manage them there. And again, LoRaWAN devices don't support custom objects. Method 3 is LoRa Device Scan and Add. This is the one we'd recommend for batch onboarding. Navigate to Scan to Add and choose Scan LoRaWAN. Configure the app key for device scanning. For Milesight devices, you can use the default Milesight key. For custom keys, you can either import a CSV list, usually provided by the manufacturer with the order, but before importing, be sure to review the file requirements, format, size, header, etc., covered in the video to ensure a successful import. Or add them manually. Both methods work for Milesight and third-party LoRaWAN devices. Click Start Scan to search for LoRa devices that match the configured app keys and gateway frequency. The scan continues even if you leave the page. You can return at any time by clicking LoRaWAN Scanning in the upper right corner of any page. When new devices are detected, the device count label turns red and turns gray after checking. You can add desired devices directly to the system. If a device has multiple model options, we recommend selecting the correct one before adding. Otherwise, the model will default to none in the device list. In that case, you can still manually edit it later. Unneeded devices can be ignored. You can also unignore them later to restore them to the list. Clicking Abandon Scan stops the current scan and clears all unadded scan devices. Next up, let's add BACnet devices and objects. For BACnet, Manual Edition works like this: name your device, pick the BACnet MS/TP as the protocol type, and fill in the details. If you've already set up a BACnet device model in the device library, just select it and the parameters will auto-populate, including objects. Now, unlike LoRa, BACnet requires you to set a device access network so you can collect data from endpoint devices. You can pick the right one and check if you have already set it up earlier under Data Acquisition, Device Access Network. You can do this right here while adding the device. For objects, if you chose a device model, all the forwardable objects will show up. Just check what you need. You can also manage them later through the object list. You can pick from the device library or add custom objects manually. And here's a nice feature: if your BACnet devices are on the same local network, you can also add objects by scanning. I will show on the next example. Method 2 BACnet supports adding objects via scanning too. Go to Scan Edition. Create an access network for your BACnet device, or select an existing one if you have already configured it. We suggest setting a smaller device instance NR range as needed to speed up scanning. Then click Next Step to start scanning for BACnet devices. Once a device is detected, stop the scan and proceed to the next step for Object Edition. Select the desired device, and scan for its supported objects, which will be displayed on the right column. You can select the ones you need immediately. After addition, you can manage objects later via the object list, either manually add new object, or by scanning for additional unadded objects. Now let's look at Modbus devices. For Modbus, Manual Edition is the only option. Name your device, choose Modbus TCP, Modbus RTU, or Modbus RTU over TCP as the protocol type. The required fill-in content is a little bit different. Here we add a Modbus TCP device as an example, filling in the required information based on your device and connection. For Modbus device, you also need to set up a device access network to collect data. You can do it right here or select the pre-configure one in the device access network module. Similar to before, if you have pre-configured a Modbus model in the device library, simply select it to autofill the parameters and directly pick its objects and confirm. Click Previous if no model is available or the existing one doesn't match. Select None for device model. There will be no objects for selection, but you can customize the objects later in the object list. After addition, you can edit the device from the device list page and manage its objects via the object list, whether you need to edit read present values, enable, disable, or add new objects. Now let's edit the device and to show you what you can do if you have select and device model. Go to the objects list. You can add objects associated with this device model from the device library, or custom new objects for the device. Then you will be able to edit, read present values, enable, disable the objects. Next, add KNX/TP devices. KNX/TP also only supports manual addition. Name your device. Select KNX/TP as the protocol type. Since there is only one KNX interface, the device access network will be automatically enabled if you have pre-configured it in the device access network module. Otherwise, you will be prompted to create one. Similar to before, if you have a pre-configured KNX device model in the device library, simply select it and enter the device's physical address. Then click Next Step to select Objects. The group address is required. It tells the gateway which KNX channel to read from or write to. Click Previous if no model is available or the existing one doesn't match. Select None for device model. In this case, no objects will be pre-selected, but you can always customize them later in the object list. You can add an custom object by filling in required parameters, and edit, read present values, enable, disable this object. Now let's edit the device and to show you what you can do if you have select and device model. Go to the objects list. You can add objects associated with this device model from the device library. Then you will be able to edit, read present values, enable, disable the objects, or custom new objects for the device. The KNX device is added successfully. Finally, add I/O devices. Head over to Data Acquisition, then I/O device. Here you can enable the I/O interface types that match your actual deployment and adjust the parameters. Except for the above methods, Batch import function allows you to import device list file to add devices in batch. You can choose between .xlsx and CSV files, but the upload rules differ slightly depending on the format. You can either download the template file to fill in device information, or export the device list from the gateway and modify it before importing back. For XLSX files, devices of different protocol types can be included in a single file, organized by separate sheets, so only one file needs to be uploaded. Now let's delete just added devices and upload again in CSV file type for demo. For CSV files, separate files must be uploaded for each protocol type. So this is how to add devices via batch import. Alright, let's talk about data read and write. The EG71 gateway lets you read device data or send commands directly to devices. Super handy for commissioning after you've got everything set up. First up, reading and writing data for LoRa devices. LoRa devices can report data based on different attributes and applications, things like reporting intervals, triggered reports, or alarms. Once you've added a device, you can just hit the right button in the device list to send payload commands and configure the LoRa device. For non-LoRa devices, click Object Count in the device list to get into the object list. Take BACnet IP device as an example. Under the Operation button, click the three dots. Then pick Get Value to read the latest value, or Write to send a value. Just keep in mind, read and write permissions depend on the data type and access mode. Now let's check I/O devices. In the I/O device list, click the 3 dots under Operation. The actions depend on the interface type. For I/O, click Force Output to set an output value. For I/O, click Force Output to toggle between closed and open. For UI, click Get Value to read instantly. And for DI count, click Reset to reset the counter. Data stream is where you can check the communication packets between connected devices and the gateway, great for troubleshooting. Once devices and objects are added, the next step is data forwarding, to integrate data with target platforms. EG71 can forward data to HTTP/MQTT servers, or operate as a BACnet/Modbus server itself, automatically converting protocols and sending data to your chosen platform. I will using some free tool to realize the data forwarding for demo. First up is HTTP forwarding. Click Add and select HTTP. Start with filling in name and description. You may optionally enable metadata for LoRa and other protocol devices. This adds lightweight context to your messages without requiring predefined objects. Next, configure the HTTP server details and specify URLs for different data types, such as uplink, acknowledgement, error, online, and offline events. Once the server is added, select the forwarding objects from the existing devices and objects created during data acquisition. To verify the setup, check the data pushed from the gateway. HTTP is ideal when you need to actively push data to a cloud API or a third-party web server. Next is MQTT forwarding. MQTT supports publish/subscribe messaging. Broker address. Enter the address of your target broker. The port depends on whether TLS is enabled, typically 1883 for plain, 8883 for TLS. Client ID is a unique identifier for the gateway on the broker. You can customize it. If your broker requires authentication, enable user credentials and enter the username and password. Or enable TLS to select certificate. We don't need here. For the data format, you've got 2 choices: combined reporting, which bundles all object data into one message, or per object reporting, which sends each object separately. And just like with HTTP, you can enable metadata for extra context. MQTT supports 9 different topics: uplink, downlink, multicast downlink, online, offline, ACK, error, request and response. Test uplink as an example. EG71 support will configuration to notify other devices that the gateway has gone offline as needed. Apply and move to pick the one of forwarding objects from the existed devcs and objects added on data acquisition. To verify, use MQTTX to subscribe to the same topic and view the incoming data. MQTT forwarding is ideal for bidirectional communication. To run as a Modbus server, configure the connection method, either Modbus TCP or Modbus RTU over TCP. Pick your network interface, and set the port, server ID, and description. Enable global objects. This automatically attaches any fixed or shared objects to every forwarding object. Apply to go to the object list and add the data objects you want to expose. To verify, use Modbus poll to connect to the gateway and read the registers. Open the object list again and select one object to get register type, register address, and data format. These are needed when the client reads the registers. And verify with Modbus poll, entering the matching parameters, and you'll get the present value. Modbus forwarding is ideal for third-party clients such as SCADA system to read data. Finally, let's configure the BACnet server. Use the standard UDP port 47808, select the network interface, for example ETH1, and set a unique device instance number along with a recognizable device name. You can also enable global objects. This automatically attaches common objects to every forwarding object, so you don't need to configure them repeatedly. If your BACnet clients are on a different subnet, you can enable BBMD and add the remote device information. After applying the settings, go to the object list and add the data objects you want to expose. If you need to adjust the global objects later, just go back to the previous page, make your changes, and apply again. Now here's a BACnet-specific feature, notification class objects. These allow you to send alerts to BACnet clients. Go to the NC Object tab, click Add, and define your alarm parameters. Then return to the device object list, click Edit on the target object, enable event detection, and link it to the notification class object. Once that's done, alerts will be sent to the BACnet client. To verify the setup, use YABE to scan or manually add the device. You'll see the object list populated. Check the present value in YABE. If the values match, the connection is working properly. Now let's test the notification. Go to Data Acquisition and send a downlink command. For example, set the valve opening to 20% to trigger an alert. Let's change the valve opening to 20% to trigger notification. Then go to Data Stream to check the downlink status. Since WT101 is a Class A device, you'll need to wait a moment for the downlink to complete. Keep refreshing the data stream until you see an ACK uplink from WT101 that confirms a successful downlink. Now go back to data forwarding and check the object's present value. It should now read 20. Open YABE again and refresh the value. You'll see a notification icon appear on the valve opening object. That means the alarm has been successfully triggered. Click it to dismiss the alert. And that's BACnet forwarding, designed specifically for building automation system integration. So there you have it. With everything configured, your EG71 is now ready to collect data from devices across different protocols and forward it wherever you need it to go.